Welcome to this course, Python Intermediate Programming, and I'm going to use this textbook, Problem Solving with Algorithm and Data Structure using Python. And lecture 1, I'm going to use Python as a pilot language for problem solving, and problem solving actually for algorithm and AI study. So here, I would like to first introduce the course series that I have. So actually, I already launched this doing math with Python. And then this one is a simple math course suitable for middle school student, 7th, 8th, 9th grade student. And then it will continue to move on to basic Python programming, and then Python intermediate programming, and Python object-oriented programming. So there are two paths. Once you pass the basic Python language part, there are two paths that you can move on. One path is you try to learn object-oriented programming and then move on to different libraries and different application domain. The other one is using Python as a language to learn data structure and the algorithm, start to be focused on problem solving. And that's what I call it intermediate programming. And the other side, I call it object-oriented programming. And then these two will move on to the last one that I call it Python advanced programming. And this one actually need to be focused on computing model. The word that I use, computing model, means fuzzy logic or neural network or 7 different AI models, learning models, so machine learning, those kind of topics, and also implement the programming language pragmatics. And the pragmatic means the mechanism that will realize the programming language. So that it actually means compiler or interpreter or syntax analyzer or tokenizer. So these are different topics, but Python is a good pilot language that can guide you from basic. This is for 7th grader up to this advanced programming that will be close to graduate level or undergraduate, senior or junior level programming. So Python for me is a pilot language, and pilot language is a language that will guide you from basic to the advanced level for programming. And I use this course to focus on the data structure and algorithm for the problem solving, and it will move on to the computing model. And let's look at the object-oriented programming part. And for object-oriented programming, as you can see right here, after you learn the class and object, you can go to the basic GUI package or Pygame to write game, or you can work on the full package like Qt, PyQt, or you can do database, JSON, or networking. So Python object-oriented programming with libraries that will allow you to actually use the classes to work on different domains. And this course that I'm talking about, the problem solving with algorithm, will be focused more on the computer science side or the problem solving side. So now let's move on to the overview of this course. So the objective is to review the idea of computer science, programming, and problem solving, to understand abstraction and the role it plays in problem solving process. So the key word here is abstraction, and what really abstraction means to us in computing. Abstraction is one of the 7 big ideas in computing or computer science. Okay, it's one of the 7 ideas. So if you go to College Board, the AP computer science principle, you can actually search through your internet and then look at the AP computer science principle. I'm sorry, I missed a science. And then you type 7 big ideas you will see that the 7 big ideas show up pretty quickly. So this is actually written down by AP Computer Science principle. Why I bring up this? It actually, you will know nowadays what's the important topics in computer science. So number one, creativity. So creativity should be something not born with you. Somebody are creative, somebody are not creative. So it's something maybe not easy to train. Then the number two is abstraction. How you can do abstraction well, and then data information, algorithm programming. So big idea 2, 3, 4, 5 actually are covered by the course we have. And then number 6, internet. Internet make big impact and then global impact. These 2, 6 and 7, and maybe part of the 3. These 3 are covered by the Python object-oriented programming part, the green Python logo course. And 2, 3, 4, 5 covered by this orange one, the problem-solving aspect. So these are the 7 big ideas that proposed by AP Computer Science principles. And these are the big idea and very important idea that as a computer scientist need to be mastering these different ideas. So that's the goal that we try to learn is the 4, 2, 3, 4, 5 that in the principle of computer science that this course will bring to everybody. So you need to understand and implement the notion of abstract data type and then use that to solve problems. So review the Python programming language as well. Getting started, problem solving with computer. That's the purpose we have for this course. We use algorithm and data structures. These are the known solution patterns. So you learn how to master these known patterns to solve problems. Also, for algorithm, you also need to learn how to develop a new design patterns. So analysis for solutions efficiency. You need to know whether the new algorithm that you develop is of good efficiency or not. So we need to study the complexity of large problem and the corresponding complexity of the solution, both the problem size and the solution, and then can tend to overshadow the fundamental idea related to the problem solving process. So basically, if the solution is too complicated, maybe your solution is not good. So basically, study how hard the problem is and how good is your solution is one of the analysis part for our problem solving process. So algorithm program, algorithm is a generic step-by-step list of instructions for solving a problem. So it actually doesn't target for some problem. It actually is a generic that can be a generic method that can be used for different applications. It is a method for solving any instance of the problem such that given a particular input, the algorithm can produce the desired result. So this one is algorithm, is generic. A program, on the other hand, is specific. So a program is an algorithm that has been encoded into some programming languages. So program has programming language dependency, algorithm no. But here we try to use our Python language as a generic programming language, as a pseudocode to help you to learn algorithm. And for this algorithm, after you learn by Python, you basically can pull the language to different other languages using the same solution. So program is a algorithm that have been encoded to some programming language. There are many, there may be many programs for the same algorithm, but depending on the programmer's language and the language they use. So what is algorithm analysis? It's very common for beginning computer science students to compare their program with one another. And then how to compare? That's what we want to study in chapter 2. This course has 2 goals: to study the algorithm and data structure, and then to compare the solutions. So what is computer science? Computer science is the study of problem solving, a problem and problem solving and the solution. And given the problem, the computer scientist's goal is to develop an algorithm step-by-step list of instructions for solving any instance of the problem that might arise. Algorithms are finite processes that, if followed, will solve the problem. So algorithms are solutions. So computer science can be thought of as the study of algorithm. That's one aspect, but actually computer science is more than that. However, we must be careful to include the fact that some problem may not have solution. So that may be too hard, may be not feasible for the machine we have at this time. Although proving that the statement is beyond the scope of this course, and the fact that some problem cannot be solved is important for those study computer science. So that may be too hard, or actually it has contradiction, so never have solution. We can carefully define computer science then by including both type of problem and stating that computer science is the study of solution to the problem as well as the study of problem with no solution. So what is programming? Programming is the process of taking algorithm and encoding it to a notion. So basically, programming is from algorithm, and you find a language, and you provide a program. And you may invent new algorithm, but basically that's a flow. That's the process of programming. And programming is for problem solving. So the whole thing here is actually computer science. And algorithm is the known design pattern or something you would like to develop. And programming language is the mechanism that help you to solve it. So these are 4 different terms, even though some people may get confused for these different terms, but they have clear definition of what is programming, what is computer science, what is algorithm, and what is programming languages. So let's look at some chart. So the evolution of the computing paradigm, we starting from mainframe computer, everybody connected through terminals to a computer. And then we had the Unix system, and then personal computing, DOS or Windows. And then we start to have client server for HTML. You download something from a website. And then we have mobile device. And now we have cloud computing, putting everything in data center. And then you browse through internet and get whatever service you have. So that's the evolution of the computing paradigms. So here, algorithm can develop implement on different programming language, and that will target for different machine and basically write different program on that machine. So basically this part is algorithm that you actually study, and then algorithm will include in data structure. And this is the topic we are talking about here, using Python in this course to study. And then you may be able to pull that same solution, even though starting from Python. You can pull to C, C++, you can pull to Java, you can pull to JavaScript. And then later you write some program on a certain machine. And this whole thing is called computer science. And then computer science, beyond the study of this, it can actually develop new algorithms and new computing paradigms. So computer science is evolving and finding new solutions. So here, let me give an example of what's algorithm and data structure. For here, we may have a depth first searching. So I'm trying to search through a tree. I have 2 ways to search it. One way is I go here, down the tree, and then up and down, and like this. This one is called depth first. Okay. There's another way that I can do searching. That's called breadth first. On the same level, I actually do this first, and then this one go down this, and then this one go down this. That's the breadth first. So there are 2 ways for searching a data, in a tree that has the depth first and also have the breadth first. Two solution, two different algorithms, and this depth first is to go down to the deep node first and then go down. That is depth first, and depth first can be implemented by a single step. To actually implement that. So basically, I start in from this point. So I push my 0 in there, and then I go down to 1. So I push 1 in there, and then 2 in there as well. Then I push down to 3. Actually, I pop out 3, 2, 1, and then go into 2, 3, 4, and 5. 3 and 4 and 5. And then I pop out everything, and then I put 2 in there, and then I go to 6 and pop out 2, something like that. So basically, right-hand side is the data structure, we call it stack. Left-hand side is the algorithm. And basically, this course is to study from the data structure side and also the algorithm side. Actually, it's very hard to divide these two topics. Some schools teach a data structure, and some schools teach algorithm, but some schools teach both together, and some schools put data structure as the first algorithm and data structure course, and some schools put data structure and then algorithm and then advanced algorithm. So there's no clear definition of what it is right here. And this course, that the textbook that we choose, you can actually get it from the internet. There's an internet version of this course. Let me see, I'm sorry. Not here, let me see. Okay, one moment, let me search for it. So basically, whatever recording I have, I'll put into this Python intermediate course on ecodehacker.com. That's my website. And here, the first item, I have this resource. And you can click on the first lecture of this course. And right here, it has an image. And there's a textbook you can download that's actually released 3.0. And this 3.0 and the website 2.0, this 3.0 actually is quite new. It has more chapters, as far as I know, than the website. So that there's a textbook that you can download. And also, if you click right here, it will lead you to this Roomstone website. It's an interactive Python Roomstone website. And this one is an online course. So for us, this one is our textbook. And it gives you the introduction, analysis of algorithm and data structure, and then basic data structures, take the collection type, and then you go to recursion, basic algorithm, and searching and sorting, and then tree searching algorithms, and then graph. So to me, this one is actually an introductory algorithm course, an introductory data structure course. It's not really too hard. So don't get scared for this this course. And that's the textbook we would use. So you can go to Roomstone Interactive. If you search from internet, you can type Roomstone Interactive Python. And there are a few courses on here. Okay, there are a few courses on here, so you can actually, there are book links, and you choose the problem solving with algorithm and data structure. That will lead you to here. And it also has other things like computer science. This one is actually the Python 1. The Python 1, very simple Python 1. If you don't know about Python, you can also go here. But this course is too easy for the student here. And let me go back. And it also has the AP Computer Science Java, but that one is actually too easy. And it also has the CS principle, big idea for programming. And that is super easy. If you pass the AP Computer Science A you really don't need to study this. That's actually too easy. And there are also the AP Computer Science A review course. That one actually, to me, the review content here is not strong enough. So I do not have strong recommendation for that. So we pretty much, there are some other courses, but here actually I will focus on this one for our course. That's our textbook.
Wait, so that's just the online class?
That's an online class. And throughout the recording, I will use this website primarily. So you don't need to buy any textbook.
Okay.
Okay, and I guarantee it's quite easy. And this one, if you, it actually is something like that. For UC Irvine's curriculum, you have ICS 31, right? That one is about the basic Python, and then go to 32, and it a little bit jump too far to 33. That one is already taking part of the advanced programming. So there is something missing. Is this maybe this one? I don't know. Maybe 32.5. This one that we are talking about is data structure and algorithm. It's missing. It's not taught in UC Irvine's curriculum. And this one would actually go to help ICS 46C. I'm sorry, no C, 46, for the C double plus data structure. That's the goal that we're trying to achieve. Okay? And the textbook is just online. And I also have the sample code. If you need the code, I can just send you the code for the whole course. It's all there. Okay? And it's some part of it actually is AP Computer Science A already. So for example, this collection I told in AP Computer Science, recursion should be some of the recursion problems are beyond AP Computer Science. Like I think the Sierpinski triangle have been covered, right? But Tower Hanoi dynamic programming is not there. These are new. And sorting and searching, like hashing is not taught in AP Computer Science. And some of the like quick sort is not there. Share sort is not there. So these are new topics. But as you can see, like up to chapter 5 is already covered by AP Computer, mostly covered by AP Computer Science. Okay. And then the new thing we need to learn is chapter 6 and 7. So that teach you the different tree. So that actually is our main focus to help students to develop the binary search tree, a valence tree or different tree, and then different graph for the nice keyword, and then there's a different graph. And if you move on to 46, I think some teachers are teaching harder than this level. But as a bridge, this one is a good course. Okay, as a bridge, this one is a good course. Good course to study in the summer before that. Okay, the next one I'm going to talk about abstraction, because I think I already talked about abstraction is one of the 7 big ideas that's very important in computer science. So what really is abstraction? From data aspect, the abstraction means in C language or any language, it doesn't matter. It just C just mean the abstraction level here. You have the primitive data type. So you actually, original data is not organized, completely not organized. So you have lowest level is primitive data type. So you have integer, you have float, you have double, those kind of data types, right? That's a primitive data types. And the data is not organized. So you actually do it one by one, and that's not efficient. So then we have the basic data structure. You have array, you have string, you have structure, you have union, right? Those are basic structure. And then use the structure and the pointer, you develop a linked list tree. So basically those 3 things. From the basic structure, you develop a vectors, or some people call it array list in Java. And I'm sorry. And you also develop the link structures. Link structure including linked list and tree. basic linked list and tree. So these are the data structure that actually are developed in basic data structure. And as you can see right here, this level actually is more like 45C in 45C in Erlang. ICS 45C is on this level using C language. And then you start to use the general purpose ADS that's called collection. Let me clean this out. The next level is collection that had the vector, that had the stack, that has the queue, that has the map. Map is actually dictionary. So this different data structure, the general purpose ADS, is on top of a basic link structure array. So most of the time we are using the array link structure and tree to implement these different general purpose ADS. So as you can see, as we move on to higher level, the data structure is more conceptual, more, the user don't need to learn too much of the computer knowledge to be able to use it. And eventually, if you go to AI, the final stage of AI is actually some people just need to build some knowledge nets, or using some knowledge sets to build some knowledge without knowing what's bits and what's bytes. So computer scientists are now trying to build AI systems so that the dumb person can actually use AI programming paradigms to solve problems. So that is the third level we have. So as you can see right here, this one's the ICS maybe 45 C is covering this. And most of the problem or project 45C is trying to implement this guy. Okay, and then the next one is word set. Word set is more like a class. So you can actually, originally you have a stack or you have a queue, and we use that to collect a set of words. So that domain specific ADS. So this one's general purpose. General purpose means that I can use that abstract data type to different application domain. But now you can actually use that for a certain word purpose, to use that stack or queue or collection. And at the top level, actually start to build application. So you actually help you to do spelling check. So spelling check is like some people who actually write something, say I write A, B, S, and then R, A, C, T, I, N. Okay, I write something like this. So this data being sent into my word set. So my word set have tons of words, and then trying to check, oh, here I miss a T maybe, and here I miss an O maybe. So it checked into a big data set, that's word set. And word set actually implemented by some vector or map or dictionary, and dictionary actually implemented by some linked list. The linked list actually contain a lot of integer. So that's how this abstraction is. But for the people who do using the searching to do spell checking, he really doesn't need to know about what's character, what's bytes, what's there. So that's the purpose for abstraction, trying to hide the technical detail from people who use it. So for the middle level, the abstract data type, the queue, set, map, and stack, these are the topics we will actually study in the data structure aspect of this course, and how to implement all of these, and also how to use the linked list to build these data structures. And then here, in addition to the abstraction had two sides. One is the data abstraction. Here is the control abstraction. So control abstraction, one part of it is called procedural abstraction. Procedural abstraction means you have a program, and the program actually use different module. Okay, and the module has a different function in there. And you just need to know that I'm using certain module, so you actually using some namespace. And then you actually get some C out or something. or you do some string compare, you really don't need to know about what's inside the module. So using namespace, the namespace itself is a module, both for C and Python. It actually is the same. And on the right-hand side, you have the encapsulation. So you have the implementation, you have interface and operation on top of it. So this actually is similar to class, but it can be a class, it can be a structure in C language. It can be either way, but both of these provide some sort of encapsulation for your data in C double plus. Okay, both class and structure can put some function into there now, and that actually is some sort of control abstraction. So object-oriented programming actually include both the control abstraction and data abstraction. So here actually I do not use the class diagram for encapsulation. I actually put something more generic, so that actually module can use this, and then structure can also use this, and I put it as a control abstraction. Sometimes control abstraction also show as the procedural abstraction. So why study data structure and abstract data type? Because we want to make the program reusable, implementation independence. Whenever you update your object, people can still use it. Just need to know about the interface compatibility, and then make your software more easy to maintain, and then provide modularization, so you can replace some module at any time that you want it. So for example, Java 8 has an update like more than 100 updates. So every time they may update some library, but you never know, your program runs still work, and they may have minor improvement, but you just don't know what's going on, because everything is in data and object-oriented programming. So it all being grouped together. So you have the information hiding and encapsulation. And that's why we want to study the data structure and making sure these can be realized. And why we study algorithm? Because we want to know about the existing design pattern of solutions. And we need to know which one is a suitable design patterns for me to use to solve some problem. And if it is not there, is the problem solvable or not solvable? And then at the end, if it is solvable, then how can I invent new solutions for it? So as a computer scientist, in addition to our ability to solve problems, we also need to know and understand solution evaluation techniques. In the end, there are often many ways to solve a problem, and finding a solution and then deciding whether it's a good solution is the task that computer scientists need to do. So here I have a chart for object-oriented programming, object-related programming, generic or functional. This is one way to look at it. Okay, there are other ways to look at it. Some people also draw this functional programming like here, and then generic is right here, and then object-oriented is right here, and then the lower part is imperative programming. Okay, some people also draw like this. Some people also like this. Actually, I like this one better, the blue one better than this one, because functional programming is bigger than generic. So here I will explain what is the relationship of these. The basic one is imperative programming. It's just statement by statement. So it's also called structured programming. So you have the loop, you have the function, you have the if statement, those kind of things, but you don't have object. But the problem is that it's not modularized. So later people invent the module. So here actually is a module or namespace for the is our structure. But none of these object related is complete. So later it developed into object-oriented programming, and it makes software more reusable. But object-oriented programming has some drawback. Say I have a stack, but I need to have a stack of the integer type, of the double type, of different type. So later they invented the generic, or in C++ you call template, right? With the template, you can develop a generic function, generic class, and generic iterator, 3 generic things. So a stack can be a stack of, say integer, or can be a stack of double, or can be stack of cars, something that you use as generic. So that's actually generic programming. And why functional is above generic? So generic can give you generic container, right? And it also give you generic sorting the function. But that's not enough. Even though your program can operate on different data type, then later introduce the functional. What is really a functional? So Eric, you have any idea about functional programming? Hello? No? Okay, functional programming is actually quite simple. If you know about calculus. So you probably know about functional programming. So you learn about, probably hear about the word lambda calculus. And what is really a calculus? Calculus is some sort of operator that you can use to do computation or some function, right? So the idea of functional programming actually is I do integration, right? 0 to t or something, and then x squared dx. Okay, I do some computation. Do I need to know what data structure it is here for the x? X may be a series. No, I don't need to know that. Do I need to worry about the type? No, I don't need to do that. So basically functional is like I just invented some function that can operate on generic data structure and also on different objects. I just need to worry about what function I need to do. Everything else taken care by the programming environment. So if you do programming in Lisp or even in Python, sometimes if you write the data right, your program read right, you just need to do some function and then the data type actually, you don't need to worry about it. At least you can always just add a pen or something. Really everything is generic and everything object oriented. You just don't need to worry about it. That's called functional programming, just like integration. You can do integration on any data type, whatever data type it is. And you just worry about the operator and the function. Is that okay?
Yeah.
So that's functional programming. But the reason why we choose Python for data structure is C++, as you see, C is procedural and structured. Okay. C++ is generic. It added template in, and then the object-oriented feature in. C11, C4, C++ 14, C++ 17, and the coming C++ 20 is functional programming. And this word functional programming because it introduced in the functional closure, and double reference. This is not the end, okay, into C++ 11. So there are several features actually added to C11, C++ 14 to make it functional. So as you can see, the programming paradigm is moving this way, and Python has all of these born into its language structure. So the characteristic of the functional programming, including first-class function and higher order function, immutable data, pure function, recursion, manipulation of this, and lazy evaluation. All of these actually Python has most of them or all of them in most of the functional programming feature. Python all has that. So that's why we use Python as a pilot language to do artificial intelligence and also the generic data structure and algorithm study. So UC Irvine has picked a good language to start the first year, and you should continue to use that. So actually it can help you to study computer science. So Python is the language for artificial intelligence. And Python is a language that the best compilation of Lisp plus Java. So Lisp is a functional programming language, and Java, object-oriented programming. So it combine the advantage of both. According to Novick, he's comparing the Lisp to Python. These two languages are very similar, both operate on lists. And then with minor difference. There also exists JPython that give access to Java GUI, like what's that? Swing, those kind of things. JPython has that. Also has CPython or different Python. And this is the reason why Peter Novick chose JPython to translate his program from his AI book. And JPython allow him to have the portable GUI demos and the portable whatever. And we know Python is more than this JPython. So it's very good to use AI language. And the benefit of using Python over other programming language for AI is good quality documentation, platform agnostic, present virtually every star Unix or Unix, Linux, whatever distribution. Python is all there. And easy and fast to learn in comparison to any OOP language. Python has many image-intensive libraries like Python Image Library, VTK, Maya 3D, Visualization Toolkit, Numeric Python, Scientific Python, PyLab, all those different numeric and scientific applications. The benefit of Python also have this. Python is well designed, fast, robust, portable, scalable, whatever for AI. Useful for real broad range of programming tasks. So we have the green codes that cover everything that can be done by programming. And last but not the least, it's also open source. So it's free to everybody. Okay, this actually is the first part of this chapter 1. It's about covering more like up to chapter 6, okay? Section 6, where I study algorithm. And then 7 to 13 is actually reviewing the Python. So right here, I'll go back to this website course. So basically, we would review the Python. So this 1.7 is just short, it's nothing, we just pass. And then 1.8 is to start with data. Okay, so data type, I think those parts are easy. We skip this one, number 1. True, false, binary, that's easy. And then less than, greater than, these are easy, and all these are easy. And then every Python data is an object, it's also easy. Built-in data types. Okay, so here, what we need to do is that there are a few operators, and they all can be overloaded, like the indexing, concatenation, repetition by star, membership in, length, and slicing. Okay, these are different operators you need to know, but I think you are okay with this. And you basically can run this program right here. That's the advantage of this course. You have the list, and times 3, you just repeat it. Now there's a question. When you do the star 3, are these same data or different? Hello? Yeah, when you do star 3, right, it actually becomes something like this. So if you change here, if you change 1, is this one the same with this one or different? If you use this times 3.
Same?
Same, yeah, it's the same. So if you want to make a difference, you actually need to do I for I, actually this one for I, in range 3, something like that. And then outside of here, you do this again.
And that'd be different?
Yeah, that would be different. That would be different. Each data will be different. You can actually build a 2D array by using that.
Yeah.
And if this pattern is not convenient, you need to do NumPy. and NumPy will give you the 2D array. Okay, NumPy will give you the 2D array. But if you times 3, actually is the set. This is called, this one times 3 is called like, is in the name of this is called shadow copy. So shadow copy is just like Python, just like Java. You actually copy the reference. So basically the reference to a object being copied 3 times. So easily the reference point to here, there's a reference point to here. 3 of them also all pointing to the same thing. So once one of it change the content, the other 2 all see. That's the effect of this times 3. That's so here I teach you shadow copy. There is a different thing called deep copy. So you need to be aware of some operator like this one. It actually is a shadow copy. So once you change the 2, it actually all 3 are affected. That's the shadow copy. Okay, so in every language has this shadow copy or deep copy issue. Okay, that's what this I try to run it, because you need to be aware that if you just copy the reference to a new array or some array element you copy there, it's not enough. The data is not copied. It's not copied. But C language do have the C double plus language do have the copy constructor. That one will be a deep copy for one level. Is that okay? That one will be a deep copy for one level, not. But there's actually, if you has a multiple level of the, you have an object, right? And that object have a reference like this, right? You have one way that you actually, for example, you have that like this. They are second level. They are several reference like this, right? There's one way that you have the most shadow copy is there's another reference actually reference to this one. The most shadow copy is like just reference to this one. That's the most low level reference. The most shallow copy, because both of them just basically pointing to the same thing. And then there could be a one level shadow deep copies that just copy this first level there. So the real deep level copy, a deep copy will be this one copy to here, and then this 3 copy the content to here, not just the reference. And then this 3, this is 6 also being copied to create a new object over here. So that's the true 100% deep copy. So deep copy is a topic, it's not a simple issue. So when you really do the data structure, just the copying itself, you need to be careful. It's not always deep copy. Okay, and right here for the whatever data structure we have in Python, Python give you tuples, right? List, and then sets, and then the last one is what? The last one is dictionary, right? This one ordered. Order means it has index. This one also ordered. This one unordered. What's the difference between ordered and unordered? So
like
this
the position.
This one is tuple. Yeah, position. Yes. This one's a list, right? This one's a set. So set, actually, some set you cannot do this.
Set is not ordered. It has random. It's all random. So
yeah, you cannot do this.
Okay. List and tuple. List is ordered, and then tuple is
tuple is ordered. Yeah, and also the dictionary is ordered, and dictionary you can just put 8 in there. So, but what is the difference between tuple and list?
Tuple, you can expand list, but you cannot expand tuple.
Yes, tuple is immutable.
Yeah.
You cannot change the content of it. you can create a new one, but you cannot replace the original.
Once you set the length,
Yeah,
you can't change
it's
it.
fixed. You can change it. Yeah. So here it said like a pen insert, pop or whatever. This is a more operator to list. Okay. So before we go into more detail, here give you a good review of what it is. Yeah, your knowledge is not bad in this this thing, so not bad. And then after that, you need to be able to, if you create that, you need to know that some function like add, R add, right, I add, they are different, right? So what's the difference between the add, R add? You still remember that?
Add is you add the right side, and then our add is the left side.
Yeah, add is like you
But
say
it doesn't
you,
matter for add. It matters for
yeah,
for
you actually have
subtraction and
A
division.
plus B, right? If this is certain class you have, this add is no problem. But there's a add this certain object. The right add, reverse add actually affected here maybe a 3, not your object, right?
Yeah, so you have to change it.
Yeah,
You have to
yeah,
change it into an object.
yeah, good. Not bad. So this part I believe you have good concept on here. So then center, count, right, adjust, or whatever. These are the operator for string. Okay, for string actually, right, left adjust just basically make the string toward left or toward right. Okay, and you have find a split. Split is like using a separator substring to separate the string into a array or a list of strings. Okay, so that the part I think you are also okay. You are okay on this, right? And left adjust, right adjust, and to lower.
Yeah.
This is simple, okay. And then the next one is the set. For set, you have a membership using in and thence, and then this one is what? This one is like this one is actually the this one is what? It's actually intersect union. I'm sorry, right? This one is union. This one n sign is actually the intersection, right? And this actually you have a set, right? You have A set and then you have B set, right? This in is like an element in A checking the element in B or A, right? And then this bar actually is like set A union, I'm sorry, U. A union B, I'm sorry, I keep writing U, I'm sorry. This bar actually means A union B. In Python, it's written down as this. It's like OR, bit level OR. And then this one intersection A set intersect with B. He actually write down this, but it actually means this. Okay, and then this is a difference, set difference. So A minus B in set in Python is also A minus B. Okay, less than is like contained by those contain function. Are you okay with this?
Yeah.
Contain means a smaller set. Okay, and then here you had a union, whatever. But these operators are easier to remember. Okay, you can also use this different function for it, but I don't think you need that. And then this index. The delete is to remove an entry from dictionary. You use indexing. If you put the key here, you find the something, right? And then if you have the in operator, is like whether the key is in there. This is the dictionary operator. I think you are okay with this, right?
Yeah.
And how to insert an item into a list, a dictionary.
You have to use the for loop.
Insertion.
Yeah.
Insertion, you need a for loop. You actually just assign a new data with a new value will be good. You just do
Wait, so you need for.
You just do like a
Oh yeah, that works too.
new key equals 3, something like that. It will work. No, this. Is that okay?
Yeah.
There's no actually specific insertion operator needed. You just need to specify it as the insertion, and then you get the keys list, right? Value list, right? An item is like key value pair, right? Okay. Right. These are okay, and get the more some item. Okay, so these are actually good. Okay, this one is the data. So we basically review the data type in Python. So now let's go to 1.9 input and output. Input and output, you had to input, these are easy, right? That's actually, and you can convert the data type to this, that's also easy. And you put a percentage sign in between a table here. Actually, it's the same with the printf in C Java, right? So that has nothing special to talk about. So this is easy, and then this one easy, right? The left adjust, and then leading 0. Okay, is that okay, right? And the only things that's different is the get value from the separate dictionary using name as key. That's the only difference, okay? But that's actually you can study this one. That is not really commonly used. And you can also use the, so basically this one is the dictionary, you define dictionary, and then you actually, if you print the item and the cost, you get this one, and actually it will put this the item banana, and then put the cost in here, the banana, and then the 24 in here, right? We put the item is banana, cost with 24 we put in here. Okay, so this is one way you can use the dictionary, but I think this is not convenient anyway. Okay, that one is not convenient anyway. So that's that. Now that's chapter 10, the control structure. Control structure, I think is also easy. While, not while, for something is easy. For each loop, that's easy. If then else, that's easy. Okay, if then else is also easy. Oh, do you know that Python actually has the, okay, more important is this part, the list comprehension. You know this comprehension, right? Basically, you can build list by using this, right? You know this, right? This called list comprehension. You still remember this, right?
Yeah, definitely.
Yeah, but there is again, not only this comprehension, Python actually has the conditional assignment. You know that? This I think you know. I think you know. But
yeah, I know this.
But let's try Python conditional assignment. I bring up this simple idle. Okay. So I can have an x equals 3 if like 1 greater than 4, right? And then else 2. I'm sorry. Okay. X equals 3 if 1 greater than 4, else 2. I'm sorry. I made a mistake. Is that okay? This is Python's conditional statement. So basically, we have like Java, right? Java, you have like integer x equals 1 greater than 4, right? And then question mark. Yes, you put 3, else you put 2, right? And this can be written in Python as this. Is that okay? I think
Yeah.
this is easy. Okay, so there's this comprehension, and it also has the this so-called conditional assignment. Okay, that's conditional assignment, and then exception. I think exception you are okay, right? Try, except, and then you can raise, and then there's a final, right? Finally, right? You are okay with this. I believe you are okay with this, right? Try, and it's quite short, right? If you have a problem, you raise something, and then there's an except, and then except with some exception object handling, right? Is that okay? Hello? Is that okay? I pass this section?
Yes.
Okay, so because this is we want to focus more on data structure, so I just make sure that introduction, just review and go through it. Defining a function, I think it's also easy. Just have the return type and no return type. So this is nothing different from any other language. Okay, so let's just go. Object oriented, you need to do freshen object. So the object, since the only thing we need to know is Python is what type of inheritance in Python? What type of inheritance in Python? It is a single inheritance or multiple inheritance?
Single.
No, Python is multiple inheritance. And Java is called mix-in inheritance. Python has single inheritance, but it allows the interface. An interface can implement multiple interface, so it's called mix-in. So mix-in to interface. But Python is basically a class A. You can inherit B, C, D, E, something. But for B, C, D, E, whatever put in here, which one constructor will be executed first? So here you say Python's multiple inheritance. You can basically do inheritance multiply. It has a multiple inheritance. So basically you can have a class name, base class 1, base class 2, base class 3. You basically do this, but that's because Python has no interface. So some of the classes actually use just like an interface, just a function, but no special thing. Is that okay? But once you do multiple inheritance, which one's super will be run? Super init will be run first. You don't remember that? If you have a class, then how can you actually call the super class constructor?
You have to put it into the constructor.
Yeah, you have to put it into the constructor, and the way you do it is that you need to do super and with parentheses, because you need to call this one to find the super class, and then underline init, underline, and then some parameter. Okay, it's not like Java is a super this is fine. No, it's not this. It's actually need to do super parentheses and then dot, something like that. Is that okay?
Yeah.
That's for the inheritance, and its inheritance is somewhat complicated. So, but normally I still suggest you to do single inheritance. Keep it easier to understand and easier to follow. Okay. Even though it has the multiple inheritance, but usually I don't find multiple inheritance to be very useful or easy to use. People just get confused. So here it has the fractional class, and I think you have done this fractional calculation in your project already, right? So you actually need to simplify it using GCD or something. So here I will let you to study this by yourself. because you already done the 30, this one is 33. In 33, you already done some of this class inheritance, and then also the over. You just study your project. Start your project one more time. Make sure you really understand the inheritance of this part, and you have done the operation of add, right? Something like this. I believe you've done this already. I know you've done this already. Okay, and then GCD algorithm right here, you can run by your subsynthesis online. And then you need to override the add, and then equals, you need to override the equals, right? It's trying to do the equal. What's the difference between this string and then the underline what's that? This one, underline replace. Which one? What's the difference between this one and this one?
One of them is you call it only for one. I can't remember now, but
Yeah.
there's a difference. One of them is I think it's just like you call it, it overloads something, and then the other one overloads something different. I forgot.
Yeah. You are right. You are very close. You are very close. Yeah. You remember most of it actually. They override for different purpose. Yes. So you can just type Python's. One is for printing function. One is for to string function. So here you check over, it has some difference between it, and the answer is well, but okay, the default implementation is use this. Okay, so this is goal is to be unambiguous, and then this goal is to be readable. So containers, this use the container type object types I'm sorry, REPR, reprint. Okay, reprint. Okay. So what this actually means? Containers str. So if you look at remember in the C++, I have the toString. In the C++, I have my generic toString. I'm sorry, the toString. You remember that one? In C++,
Yeah.
I write down something like that, and the other one I do this. So it actually suggests that this reprint is this one is this one. You know what I'm saying? So the containers, the toString actually is this, and then the reprint actually is this to a certain primitive data type. You know what I'm saying? So basically, toString is to use the containers this, and it is used whenever toString is called. And reprint is actually just focus on some data field to convert. But in fact, you need to implement both of them in your class. Okay, you need to implement. So the goal of this is unambiguous. So let's come to read about whatever here, and this is to make it readable. So you can actually the containers, it will need this. Okay, so basically, if you remember the way I differentiated you between implement this for any class you implement. So basically, you need to do this for every class you actually implement. Okay, that's safe. Okay, so always do this for every class. That is the toString, basic toString for the object. So that's the lowercase toString. This should be second nature. Implement toString. If you think it will be useful to have string version of the errors inside the more. So if you think that you will implement this, if you actually combine everything into some condition that it will automatically use concatenation or something, you should do this. Okay?
Uh-huh.
Yeah, something like that. So usually this one is for basic class. You can always use that to do that. So basically you can print this. Okay, so yeah, you just remember the way I differentiate. That's good enough. Okay, so that one is that. Add equal, that should be easy. Logic gate, this one is a example. So it tells you the super classes. You can have multiple super classes. So I mean, is a relationship. This should be easy. Okay, this is just a example. So basically here, this one is a logic gate and circuit. Okay. Here I think the object part is not hard. I just want you to learn this different logic gate because it's good for ICS 51. So this one is called N gate. N gate is just like you have two terminal, one, you will get one, otherwise you will get zero. And then if there is a bubble, this one, okay. I actually want you to learn this because it's in 51, you will learn this. This one's the N gate. So basically you have a signal, electrical signal here, and you will create C, right? So C basically will be if A equals 0, 1 here, B equals 0, 1 here, and then the result will be here 1, right? That's actually the truth table for C as a function like this. But this one, if there is a bubble, if there is a bubble over there, this one actually called named, not end, not an end, okay? So basically, the logic of this one is like C equals A and B. And it actually equals A bar plus B bar. It actually equals, it's also called this one actually equivalent to A inverse and then have an OR gate after that. It's also equivalent to this. NAND gate also equal to this. Okay, this is something that you need to learn in 51 and assembly. So that one's N gate, this one's OR gate. This one is called NOT gate. NOT gate is inverted signal. So a single triangle is called amplifier. So actually, you have signal, it probably 5 volt. Over here, maybe become 10 volt. That's actually called amplifier. But this amplifier with name is a bubble, that means not A or A bar. Okay? So the logic 0 get 1, 1 get 0. Okay? That's actually something I don't really care about this class, but I do want you to learn this. And then there is something called NAND gate. If there is a bubble over there, that's NAND gate. This one actually is equivalent to A dot B bar and equal to A bar plus B bar. Okay, these are something you need to learn in your, and then this OR bar, OR is this one called named. This one called NOR. It actually equivalent to A plus B bar equivalent to A bar dot B bar. Okay? And then if there is something like this, there is a circle, half circle there. This one is inclusive OR, the equivalent to A, B, A bar B, or B, B, A bar. But you cannot have A and B both are 1. Is that okay? And the logic is actually 1, 1, 0, 0. Is that okay? That's called inclusive OR if you have this. And then there is another one called inclusive NOR. Inclusive NOR is actually this, and then there's a bubble there. This one's called inclusive NOR. This one's inclusive NOR. X means inclusive, and that one is actually A bar B bar plus A bar B bar, right? So it becomes what? A B bar and A bar B bar, and then it becomes A bar plus B and A plus B bar.
Mm-hmm.
Okay, whatever, you will figure it out, okay? And this one actually means, this one by this logic equivalence is hard to understand. But if you actually look at the truth table, it will be easier, okay? Because inclusive OR is what? Inclusive OR, sometimes if you look at this logic function, it's actually hard to know what it is. But if you look at truth table, originally inclusive OR is like this. The inclusive OR is like this.
Mm-hmm.
Inclusive OR is like this. So inclusive NOR is actually just, is that okay?
Yeah.
That's easier to understand. Inclusive NOR is just like this. And your fresh memory, your fresh memory, if you buy like SD card, right, to store your image, you have they have a name type and then NOR type. Okay, that's fresh memory. There's a name fresh memory, okay? So fresh memory have two types, one's a name type, one's NOR type. That's a fresh memory. So there's a one type called name fresh and one type called NOR fresh.
Mm-hmm.
Okay, and name itself can be logic complete. Name itself can be logic complete. What is a logic complete? The logic complete means that I have the not, and or three function, right? But all of these three functions can be implemented by a single name. So for example, if you have this one with name gate, right? If I connect these together, I have an A. This one will be A bar. So this one implement this. This one is equivalent to this.
Mm-hmm.
Is that okay? And this one, if I have this one, right, and I put this over there, so this one itself is a inverter at the end, right? This one is an inverter at the end. So I put this one A, B over here. So I use two NAND gate, one NAND gate, two NAND gate. I get A and B over here. Is that okay?
Yeah.
So this one is implement, third one is OR. Third one is OR. Third one is OR. So that means implement the third one OR. Third one OR, actually, I give you some hint already, because my NAND gate itself is equivalent to this bubble OR, right? By De Morgan rule. By the what's that? Yeah, by De Morgan rule, right? A B bar equals A bar plus B bar, right? So here I put two NAND gate in front of it, like two inverter. This one equivalent to OR, and this one has the same function as this one. Is that okay?
Yeah.
Need more explanation or no?
No.
Okay, so basically that is a logic complete family. So I use a single NAND gate that can program for everything. So every logic I can actually use a NAND gate to do everything. So when I store some program or store something onto my flash memory, I can just use a sea of gates of NAND gates. So you actually in here say sea of gates. So on a chip, there's a sea of gates. Just do a lot of sea of gates. And then those seas of gates, everyone is a NAND gate. You just build a lot of sea of gates. You just design a lot of NAND gate on a chip, and then you program it. Every time you can program for different purpose. Every time you can program for different purpose. So you can store everything onto your static memory by just programming the sea of gates. So if you do that like SSD, those are SSD devices, it's just a NAND gate. A NAND gate actually can be to be used as a sea of gates. So tons of gate over there, and then you just program it, and you become a processor or something for you. That's called sea of gate. So on the chip, it doesn't design any logic at all. It just put a lot of NAND gate over there, try to connect those NAND gate together, and then those NAND gate can compute like a computer. That's called sea of gates. Programmer device. You can use a programmer to program the device, and it become a chip that for your computing purpose. Okay, that's called sea of gates. And in 51 course, you will need to study these. As I mentioned, you actually need to know that how these things are implemented and making sure it's actually logic complete. So here actually has some listing of the gates, which one get the output and get the pin or whatever. And so it's actually a study of these different gates and pins to using Python to study it. Okay, and I have the code you can actually download and then can run. Okay, so it actually just help you to connect some gate together and perform some function. Okay, so right here, let's see, here you see that it actually has a logic gate, and logic gate actually had the binary gate that actually implement the logic gate, extend the logic gate, I'm sorry. And then an AND gate extend the binary gate, and then OR gate, it has an AND gate, NOT gate, and the unary gate, the NOT gates, and then there's a connect class, and then there's a main function. So here actually is the AND gate G1, AND gate G2, and then OR gate G3, and then NOT gate G4, and then connected G1, G2, G3 to C1. That's a connection one. Okay, so basically, let's draw this diagram. You have a AND gate G1. Let's call this G1. You have another AND gate called G2. You have an OR gate G3. Okay, so this one is G3. And then NOT gate G4. Okay, and it connect actually has a connection of G1, G3. So it's something like this. You connect G2 to G3. So this is the connection 1, connection 2. Okay, and then connection 3 is G3 to G4. Right? And then you actually get the output for it. Is that okay? So basically you have the data sending in here, and then you actually will get the data out from here. Right? So that's actually move up a little bit. Move up a little bit. That's what it is, right? It's a connector. So basically you can, this is the hierarchy that it used. and then it basically trying to implement this, right? It's a G1, G2, G3, G4, just like these connection together. Okay, so that's the logic gate that you will face in 51 course. And here it actually used that to teach you the inheritance. So you go to here and then study this, you will have some idea of what is inheritance. Okay, so this chapter pretty much just talk about basic idea of Python and then review the topics. So here we finish the object-oriented and then inheritance and then summary for the chapter. Okay, this one's easy here. So now actually the key terms for 50 and then 60, you can look at it. But I do want you to actually go through the exercise. Okay, here has the exercise. Go through that to review your Python 33. Okay, and after that, next week we will talk about big O notation, this dictionary. Okay, and then we follow that, then recursion, and then you need to know about dynamic programming. Okay, you need to know about the dynamic programming because ICS 46C. This one's in. Let me see. It's not this guy. I want this guy's code content. Okay. Oh no, there is no C. So if you look at this guy's, okay. So basically linked list or whatever, right? Recursion, right? Recursion. Sorting something and then binary tree, different tree, heap tree, AVL tree, right? AVL tree, hash table, midterm, and then sorting come out, right? Graph theory, right? Compute memory, and actually this guy also had a dynamic programming somewhere. I do not find it. Okay, so basically I'm not kidding. Actually, several topic actually is covered by whatever you see right here, right? So basically that course actually covered by here. But now you use the language you know more, using Python to study first, and then pick up your C++, and then you should be able to be ready for your even if you take this guy's course, you will be ready. But you need to learn the temporary library. I think you are not ready here, right? For C++, you pick up this first.
Yeah.
If you actually eventually take the course from this guy, and that is the algorithm. So that's why I want you to get to study this Python course. Because if you use C++, probably you are not able to make it with too many things. But this one actually is like 417. Okay, so that's what we have. So that's it for today. Is that okay?
Yeah.
Okay, bye now.
Bye.